All right, hello everyone. September 23rd. Oh, what a day. What a day. I was definitely very, very exhausted at the moment. Struggle against SQL alchemy. SQL alchemy is an interesting stuff, but this is a lot of hidden knowledge in it. If you want to translate every SQL, I think it's possible to translate every single SQL um, statement into SQL alchemy, but it just takes efforts, lots and lots of efforts. I got the SQL done actually last night, but today I think I spent, I don't know, 2, 3, 4 hours just trying to translate it into SQL alchemy. I I don't even know. I mean, I'm still debating with myself whether to, continue with SQL alchemy or just use pure SQL. I'm leaning towards SQL alchemy. I have two reasons for this. First is SQL injection, right? If you use pure string, there's a chance, and you have to do escaping the characters, or you have to use PG, right? I mean, if we want to use PG, why don't we just use it directly? I mean, we bought into Fast API, so we're gonna do SQL alchemy. But it's always a fallback, right? If the query is just way too complicated, yeah, we should just go with it. But the more important reason, benefit is you can do conditional queries, right? If something happens, you query this. If something happens, you query that. Now, I guess you can do that in SQL, but I don't know. I don't want to know, right? Right now, it's in SQL Alchemy, you are writing in Python, so you just know if and else, right? If else statement, straightforward, simple. If you want to manipulate string, the SQL string, that's a whole another can of worm. You don't want to open that. So, yeah, I guess just keep digging into it. Eventually, you will be good at alchemy, and then yeah, you won't be worried. But I think will still write a SQL first, and then convert it into SQL alchemy. All right, let's take a look at this. Longest string chain. You're given an array of words, where each word consists of lowercase English letters. So word A is a predecessor. Oh shoot, I forgot to do Spanish today. Damn. Um, I'll leave it outside so I can always look at it so that I won't forget. All right, A is a predecessor of B if and only if we can insert exactly one letter anywhere in word A without changing the order of the other characters to make it equal to B. For example, ABC is predecessor of ABAC, while CBA is not a predecessor of BCAD. A word chain is a sequence of words, okay, with k large equal to 1, where word 1 is a predecessor of word 2, word 2 is a predecessor of word 3, and so on. A single word is trivially a word chain of k equal to 1. Return the length of the longest possible word chain with words chosen from the given list of words. Basically, you start from something and then you keep adding to it, right? You keep adding to it. And there are conditions because, well, first of all, the length is only 1,000, so some brute force-ish idea you can go with that. And each word is 16. Well, if the chain need to form, it has to be length 1, length 2, length 3, length 4, right? Because each new word must be one bigger than the predecessor, okay? So what can we do? Well, let's just say we group the words by their length, okay? So in the first case, I have length is 1, we have A and B. Length is 2, we have BA. Length is 3, we have BCA, BDA, and that's it. Length 4 is BDCA. Okay, so we want to find, so basically there will be some links, and then we want to find a path, right? From the longest path, that's what we want to find. So how can we first maybe identify if we have any path? Oh, are we gonna brute force the path? Dude, brute force the path. I mean, how can we fast to determine if A and this? Which means we need to add a value, add a letter. Oh yeah, I think we can do that. We check this, see if there's only one additional. If there is, we just add it to it and see if it matches. If it matches, then we have we're gonna have a graph. Yes, we're gonna have a graph. Okay, we're gonna have a graph with like this is the length, right? And we'll have actually this is the level, right? This is maybe we can do BFS, right? So this is the start, and then we try to see if we can move to this. We try to see if we can move this. Try to see if we can move to this. So we just need to write a function to check. Okay. All right, let's give it a shot. We're gonna go with that idea. Where is my? Here it is. Okay, so we need to first length, right? So we need to have a hash map of integer and a list of what? String. Okay, so will be size map. Okay, then what we're gonna do is for const word const. Come on, it's not JavaScript. Okay, then for each one we say size map dot put if absent word dot length size length new array list, and then size map dot get word dot length dot add word. Okay, right, and that's it. So we build that. Now the queue, we should say the size. What will be the smallest size? Smallest size. I do need the smallest size, so we probably need to have int min size. Integer dot infinite, no, max, right? And then we say min size max dot min size word dot length. Okay, so now we go through all this. We're gonna do a queue list. We can do queue. Queue of what? Int. Queue equals new linked list. I remember it's a linked list, right? That's a queue. And to start, right? For start, we need to say for string word of size map dot get min size q dot add new int. So two value. One is the, oh shoot, that is a shoot. It's a mix. Oh, what am I gonna do with that? You I don't know. Like, do we have to compute? Yeah, I guess we have to. So we do, I don't know, class, pair, string, word, int. Int is what? Length, size. Ooh, size. I guess we don't need. We just need to push that one in. I have the size, right? It's the current size. Now we push the next one. Yeah, hold a second. I think string is be good enough. Because it's the size, right? You know, I get the size. So we're just gonna q dot add word. Okay, just initialize this thing. Okay, so now we have this. We say while q is not empty. Q dot add all. With parameter. No. Can be parameterized constructor call. I have no idea what this one's gonna do. Oh, I did not know this one exists. Holy crap. That is good. All right, so we have a queue. And now we can say string current word q.poll, right? Then we'll see if a link exists, right? Then for string next word of size map dot get or default current word dot length plus 1. What is the default value? Collections dot empty list. I remember empty list, you should put something inside. Wait, hold on. I remember we need to put something inside. Java collect empty list. Oh, I guess it's fine. Yeah, I guess you can just call empty list. Okay, I just do empty list. So we say for each, now is where we need to put a function. So it would be let's say private boolean is predecessor, right? Is predecessor. So is predecessor would 1. Okay, so say string would 1, string would 2. Right. So we can say true, return true if would 1 is a predecessor of would 2. Okay. So basically we need to go through and then find out whichever one is not the same, right? Whichever one is not the same, then how do we check which one is not the same? So we just go through, right? We go through and yeah, I want to have a better way to compare these two. I need to know which one does not exist. Can we use set? I think I can use set. Right? Set. Java set. Minus another set. Difference between the two sets, exactly. Okay, now we need to turn, convert. Oh, that's actually not right because you might have duplicated. Nope. Oh, I can remove 1 from word 2 and compare to word 1. Okay, so Java, let's say string, remove character. Replace. Yeah, I need the index. Substring. Ugh. Yeah, I'll use this. Oh, they answer almost at the same time. I think both are the same, right? Substring. Yeah, I'll use that. So basically, we're gonna go through all the indices. So for int I equal to 0, I smaller than would 2 dot length I plus plus. So for each one, we say number of matches, right? It should have exactly 1 match. Oh, that's also not right. Because the predecessor, hold on. If we can insert exactly 1 letter without changing the order, that means if we remove, yeah, as long as I have 1, then that's correct. Then we say yeah, we put on a string mod word 2. Okay, so say mod word 2 will equal to word 2 dot substring. Okay, substring we have int and int. from to. So from 0 to I plus word 2 dot substring from I plus 1 to the end. That's the one, right? The substring is 0 to index plus substring. Yes. So now we do that, we get a new word, and then we say if word 1 dot equals word mod word 2, then we just return true. Otherwise, we'll return false. Right? Good. Now we say for each next word, if is predecessor, current word, and next word. If this is true, then q.add next word. Okay? And we need to record, that's what this length, right? So we say int result shall be 1 already, because we have one word. And then you know what, probably not. I'll just int shall be 0 every time I get one. Ooh, no. What we shall do is well, I have the minimum, so I just need to know the maximum. The maximum, okay, the max, yes, I can use max. Yeah, otherwise you do have to pass in. Oh, I guess it's fine. It's fine. We don't have to do this. We just do this, right? Blah, 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 blah. At the end, oh, let's put the string current word on the outside. So if it's on the outside, we'll do this, and eventually the current word will have the longest size. So we can just return current word length minus minimum size plus 1. That shall be the total. Okay, so what do we do? Initialize. Yeah, we do need to initialize. String mod, no. Min size. How to initialize a string? Initialize string with length. String builder. String utility. Apache, no, we don't have Apache. Repeat, do I have a repeat? Repeat. Can we do this? Dot repeat. Yes. Oh yeah, min size. Okay, so with that, let's give this a shovel. Did it work? Looks good. I have confidence in this one. Let's add a test case. So little test case. Okay. Nope, it's not a position. One zero four eight. Straightforward, right? BFS, right? The starting queue is create a map where the key is the length of each word and the values. The value is a list of words. Then use BFS. The starting queue is the list of words with the smallest length, size, length. And each for each word, we go through all the words with one more in length. Check whether the current word, current and next word can form a predecessor relationship. If they can, we push the new word to the queue. The answer is the last word, that is the word with the max possible length of the last word minus the length of the first of the main length, right? Minus the main length and then plus 1. So on to go through this, on to go through this. This is shall be on as well, and I just realized it shall be a set instead of yeah, it shall be a set, because in this case it could be duplicated, right? It could be duplicated, so we need visited. So queue and set string visited equals new hash set. Can we do this the same? I guess we can. So current word, right? If visited dot contains next word, and so if it does not contain next word, so now I can say it's on. Yeah, earlier is actually not, because let's go through. So on times m, where n is length of words and m is the average size of each word. Okay. Still good? Oh no, I forgot to add if this queue.add visited.add next word. Okay, the shot. Oh, I was preparing to end today. Oh. max. I know what's wrong. I know what's wrong. Current word, and then int max size. Oh, we can just do 0. Actually, this is not right. Main size. Okay. So every time when we push, I'm gonna say max size equal to max size next to word or size or length. Maybe I'll do it up there. That will be current. Alright, current word or length. I'll keep going to the last one. So now here, change to max size. Okay, so now we have a little bit change. Oh! That is interesting. That is very interesting. All right, I don't know what happened. We have to check words. Wasted my time. Well, if you can do it right the first time, it won't waste your time. All right, that's fine. We will stop here and let's debug. Sorry, this is unexpected. Let's debug. Okay. Size map. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Value. Okay, let's just randomly pick. Size should be 6. 1, 2, 3, 4, 5, 6. Okay, that's fine. Okay, okie dokie. Q is 2. Visited is 2. Okay, let's go. Current. Where's current word? Okay, current word here. So max size equal to 2. And then current word is 2 plus 1 is 3. So next word KSS is true, right? KSS put into it. Next, GRU, that's false. Next one. Oh, I think it's get out. Next is GR. KSS, no good. GRU, that's good. Nothing. Okay, next one. KSS. That's no good. That's no good. That's good. Okay. No good. That's good. That's no good. Okay. Next, KSSQ. No good. KSSQ. Yes, good. Yep. That's no good. No good. Okay. GRU. No good. No good. This is good. Good. Five. Right? We got a 5. No good. No good. Yes. Okay. No good. Yes. No good. 6. That's good. No good. No good. No good. No good. Dancing is a good. Yep. Seven. Getting closer. I didn't see. Okay, no good. Yep. I think I get out. But did the queue become empty? Right. Okay, yes. So we can go to this level. Okay, this is Q and GRU. Oh, maybe we start from here. Oh. It doesn't necessarily start from the smallest. I see where the problem is. It doesn't necessarily have to start. Well, we do start with the smallest, but each time I'm gonna change the idea. I think it will be like a DP. I think it'll be a DP. I think we'll sort it based on the size. And I'll go right to left. For each one, if it's the same, now we don't go. If it's small, we go through everything. No. Mm-mm. want to change this idea. We need a new map. We have a size map. We don't even need a min size. We need a max size. Max size, right? Max. Okay. Then we need a new map of string to integer. We call it memo. Okay. Then we have, yeah, how many steps, right? How many steps? And we say for string actually it's fine. Those will should be 1, right? And yeah. So for int s equal to max size, s large equal to 1, s minus minus. Okay. So for each s, actually we can start from max size minus 1. And int res shall equal to 1. Okay. Now for each size, we just say for string word of size map dot get s, right? For each one, we will go through. We can say memo dot put word zero. Okay. Then we'll say for string, okay, current next word size map get s plus 1. Okay, so for next word, I say if is predecessor current word next word, then memo dot put current word max dot maximum memo dot get current word memo dot get next word get or default next word default with 1 plus 1. Okay, so once we're done, current word for each word, once we're done, res max dot maximum memo dot get current word. All right, I don't like to call it memo, so I'm going to change it. Call it DP. Okay, then use DP. Then use DP to find the max sequence, max count, max length of word chain starting from each word, from large word size to small word size, and find okay, let's see, is this one right? Get is no. $37. Or default collections.empty list. This one work? Yep. I think this one makes more sense, huh? I'm gonna flip out, man. So I start from here, right? So AB, so I'll put AB and put into 0. Maybe I should put into 1 instead of 0. But I don't understand why would this make a difference? Oh, it does make a difference. It does make a difference. Because the next word will have it. Yo! Oh. Is that why we have so many wrong answers in the last time? Nah, this is just oversight. See, this is like in the interview. It will be fine. Yeah, we do it too fast. Get all default. It will be fine because unless they have prepared all these special test cases, usually they just go with the easiest test case. Like honestly, the easiest. So you just need your code to run for the easiest, and then it will work. Oh my god. It was terrible. That was absolutely terrible. Let's run the same runtime as Python. Man. This is so bad. runtime is so bad. But at least that's a solution. All right, why? That's the answer. There's a question, and why is it so bad? Are we computing things we're not supposed to? Yeah, it has to be. I mean, otherwise, for each one we go through the whole thing. Next one we go through the whole thing. Next one, that's all on. That's not on at all. I think that is on squared. I think it's on squared. Because each one, right? You should look at this. Everything will go through the whole thing, right? You compare. And the next one will compare. Yeah, so everybody will compare to everybody else. If we can make a match, that's an interesting idea. No, but you have to go through 26 times. Right? You add A had to add at different positions. B had to add different positions. Compared to everything. The question is just which one is faster. No, this one's faster. Make the check for predecessor faster by adding letter to the smaller word and directly check if the new version, right? If the new version exists in the next word, since each word is of size 16, right, and there are only 26 letters, it should be faster to check this way than a loop of loop, than a nested loop. Okay, so basically the idea is for each current word we do this, that's fine, but we don't do that. Okay, we will go through the 26 letters. All right, how do I go through the 26 letters? Oh, you can do, oh wow. string insert character. String builder. I like this one. We'll do that. But it has to be a string though. Should I just string the value of? Yeah. String the value of. Okay, so now I have all the pieces. So we need to loop through the thing first, which using this. Okay. So for char, C equals A, C smaller than this, C plus plus, C plus plus. Okay, I don't like that. I like this. Next word. Okay, so we say next word shall equal to current word. Oh shoot! I also need to go through the current word. Darn. It's okay. That's okay. That's okay. So we can say next was dot substring. Right, 0 to I plus string dot value of C plus current word dot substring I towards the end. That is to add the C to it. So now I have next value, a next word. Then we just say dp dot put, right, current word, and then max dot max dp dot get current word dot get. Oh, we shall start from the max size now. Get or default next word 0. Plus 1, right? That makes sense to me. Then we just go through all of them, right? And at the end, once this get out, I do this. All right, let's try see if this one's right at least. Oh God, it's not right. How? Why? Oh, I see. Because you're doing a maximum. Well, that should be fine, right? Yeah, it should be fine. You have at the end it'll be 1, and then you go the next one. So that one should be 2, right? 3, 4, 5. Whoa, why? Next word by doing the substring stuff. So we get the next word, right? Now we check if it's in there. DP, if it's in there, I get the next word and a +1. That would be my current one. Interesting that this is not right. I guess we have to debug again. Yeah, I don't understand. Okay, so S current word. Oh god. I didn't have like 2. Okay, can I like step over, step into, step out? Okay, step out is what? Shift F8. Okay. So now actually I probably need it for all 3 of them. So I can just get out whenever I want it. Okay, so current word we know, so we can step out, step out. It doesn't work. Why you keep doing this? How do I get out of the loop faster? I don't know. Maybe the step out. Maybe I don't do it here. Maybe I do it here. F8, come in, and then we can do step out. There we go. Okay. Next one. I have next one. S is 9. I really have no idea, but I have to go through all of them. And then oh, they shall match, right? So they shall match, which means if I step out, DP size is 2. So F8, result is 2. Good. Next one. S is 8. Okay, S is 8. Yeah, that one shall match as well. So shift this. 3. Good. Next one is 7. Now 7 I have 3. So I have to go through all of them. But one of them will match. Okay. So this one does not match. Size is 4. That's good. TP size for rest is still 3. Rest is still 3. 1, 2, 3. No, wait, hold on. The Z shall match. Didn't match. Oh. Smaller equal to. There we go. Oh, smaller equal to. That was. Okie dokie. Alright. This one, let's check. Alright. Let's see if this one will be faster. Nope. Well, I guess maybe we can optimize yet again. That if I get a new value, then I just skip out. Okay? So, blah blah blah, dot put. Yeah, as long as it's one larger, then, but how do you know? Without going through the whole thing. I don't know. It's actually slower. Haha. It is actually slower. All right, I'm out of ideas. Oh, maybe because the increase in test size. SDP solution. Yeah, I think this is my solution too. You sort, get a min, set it to this. You remove. Yeah, that's exactly the same, but I didn't have to go through. All right, so I don't think. Yeah, you don't have to do the map. update. No need to do the map. Just sort words by length. Alright, so this map, let's do the size map. So I just need to say collection, or I can just say words dot sort. No, arrays dot sort words comparator comparing int w dot length. Can we do that? Oh, wow, okay. And then we don't need all of this. This is needed. Result is needed. Right? Then we go through words one by one. And every time we go through words, we just go to the previous one. Right? I think that's what it is. We go through the previous one. Now, we don't go through the previous one. We just for the current one. For string word of words. We say for each one of them, we remove. We remove will always be easier. For int I smaller than word dot length, I plus plus, pre-word, right? Pre-word shall equal to substring 0 to I plus word dot substring I plus 1, right? And then we say dp dot put word dp dot get or default. No, max this word 1 or dp dot get or default. Pre-word 1 0 plus 1. All right. So put a word either as 1 or yeah. So we'll do that. Once we're done, res equal to path.max res dp.get word. And at the end, we'll return res. Is this right? Yeah. Oh. Yeah, like almost there, but so close but so far away. That's the one. Massive difference. Massive difference. So when log in, you sort it, and each one you remove, that's like 16. That's O(n), n times 16. Yeah, how did we not figure it out? We use DP, we use all the other fancy ideas, but none of them works. All right, that will be it. That's way longer than I would want. 1 hour 15. All right, I'll see you guys tomorrow. Adios.